Combination series parallel circuit problems involve a pretty stepwise redrawing of the circuit. Go ahead and name my resistors. I'll call this one 1, 2, 3, 4, and 5. I will then redraw the circuit, simplifying resistors 3 and 4. Since they're wired up in series with one another, they're easy to redraw. Okay. Let's redraw it again, now simplifying resistors 2 and resistors 3 through 4, treating them as a single resistor. But first we have to figure out what their total resistance would be. Total resistance in parallel circuits. Resistance in parallel for resistors 2, 3, and 4 is equal to okay. Now I can redraw it one more time. Okay. Now I'm prepared to do totals. Total resistance equal to 20.88 ohms. Total voltage, 12. Using my vert triangle, I can solve for my total current. Using the vert triangle appropriately, total current is equal to total voltage divided by total resistance. Now I can solve for potential difference or voltage drop across my 3 resistors. Resistor 1, resistors 2 through 4, and resistor 5. Labeling them from the previous diagram, as displayed up here. Rationalizing resistors 2 through 4 as a single resistor with 7.88 ohms. The voltage drop, or potential difference across each resistor, will be different since they're wired up in series. Voltage drop using my appropriate vert triangle. Let me zoom up on that so that way I can have some more room to work real quick. There we go. Voltage drop is going to be equal to the current times the resistance of that resistor. In the case of resistance 1, the voltage drop would be equal to 2.88 volts. In the case of resistors 2 through 4, voltage drop would be equal to current, which will be the same for all 3 resistors in this particular series circuit, times that resistance. Voltage drop across resistors 2 through 4 is equal to 4.53 volts. Voltage drop across resistor 5 is equal to current times resistance of that resistor. Voltage drop across resistor 5 is equal to 4.6 volts. We can make sure that we've done this properly by adding up these 3 voltage drops. Summing it up and being in keeping with Kirchhoff's loop rules, that the true voltage of the circuit is equal to the source voltage. Essentially equal. Good. Potential questions we can ask involve perhaps current placement through resistors 2, 3, and 4. This is resistor 2. This is resistors 3 through 4. Because they're in parallel with one another, the current splits before reaching these two sets of resistors. Our current, as emitted from here, we've solved earlier, was equal to 0.575 amps. Our current splits, and some of it travels this direction, and some of it travels this direction. They meet back up after this junction, and 0.575 amps travels through resistor 5, and 0.575 amps makes its way back to the battery. Current be analogous to electron flow or water flow. To solve for how much current travels through resistor 2 and resistors 3 through 4, we can use Verr triangles appropriately. We've already learned what the potential drop is across resistors 2 through 4. The potential drop across resistors 2 through 4 Therefore, the potential, or the current, across resistor 2, to solve for how much of that current chooses to go through the resistor 2, the 20 ohm resistor, that's going to be equal to voltage divided by resistance. To figure out how much current is traveling through resistors 3 through 4, a similar procedure. We can make sure we did right by adding up those two current values. If they equal our cumulative current, we know, which we solved for earlier, 0.575, we know we did good. I get 0.58 amps. If you notice, more current travels through resistors 3 through 4 than through resistor 2. Current prefers resistors of less resistance. Therefore, 0.35 amps traveled through there. Finally, to solve for the potential difference across resistors 3 and 4. We know that the potential difference across resistor 2 is equal to 4.53. But that potential difference will be split across resistors 3 and 4, since they're in tied with series with one another. The current traveling through resistors 4, 3, and 4 we've solved for earlier. We can now solve for potential difference or voltage drop across those two resistors, knowing that we have a total potential difference or voltage drop across those two resistors of 4.53 volts. How much does it get broken down? Well, we can use the Verr triangle on each of those. Solving for the voltage drop using current values, 0.35, which are pretty consistent, and 9 is this resistance. Same thing over here. It would be 3.35 times 4 is that resistance. Voltage drop across resistor 3 is equal to 3.15 volts. Voltage drop across resistor 4 is equal to 1.4 volts. All right, that's a lot of work, but now you can answer any questions about series and combination circuits.